Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the starting material. The starting material is 1,4-hydroxycyclohexyl acetophenone, a benzene ring bearing an acetyl group, C is equal to O, CH3, and attached at its para, or meta, as drawn, position to C1 of a cyclohexane ring that has an OH C4. Step 2. Reaction A. Clemmensen reduction, Zn, Hg, HCl. The Clemmensen reduction converts a carbonyl group, C is equal to O, directly to a CH2 group under strongly acidic conditions. The ketone C is equal to O, CH3 on the benzene ring is reduced to CH2CH3, an ethyl group. The cyclohexane ring and its O substituent are not affected by acidic Clemmensen conditions. Alcohols are stable to Zn, Hg, HCl. Therefore, product A retains the O on the cyclohexane ring and now has an ethyl group on the benzene ring. This matches structure Q. Let us re-examine. Q has Cl, not O. Structure P has O and an ethyl group on the benzene ring with a fully saturated cyclohexane, but wait, P shows OH C4 of cyclohexane and a 3-ethylphenyl group. However, under Clemmensen, HCl, an allylic alcoholic, O can sometimes be replaced by Cl, but a simple secondary alcohol on a cyclohexane ring under Zn, Hg, HCl can undergo substitution to give the chloride. Actually, Clemmensen conditions, concentrated HCl, can convert the secondary alcohol of to Cl, since HCl can substitute Cl in secondary alcohols, especially under heating. Therefore, the OH C4 of the cyclohexane is converted to Cl, and the ketone is reduced to CH2CH3. This gives a product with Cl on the cyclohexane and CH2CH3 on the benzene ring, which is structure Q, fully saturated cyclohexane with Cl and ethylphenyl. So A is equal to Q. Step 3. Reaction B. Wolff-Kishner reduction, NH2NH2O delta. The Wolff-Kishner reduction converts a carbonyl group, C is equal to O, to CH2 under basic conditions. The ketone C is equal to O, CH3, CH2CH3. The O on the cyclohexane ring is not affected under basic conditions. Alcohols are stable to base. Therefore, product B has O on the cyclohexane and an ethyl group on the benzene ring, which matches structure P. So B is equal to P. Step 4. Verify why other options fail. Option A is equal to P. B is equal to question wrong, because Clemmensen, acidic, should convert off to Cl giving Q not P, and Wolff-Kishner, basic, preserves of giving P not Q. Option B. A is equal to Q, B is equal to R, wrong, because Wolff-Kishner does not introduce a double bond into the cyclohexane ring. R has a ring double bond which is not expected. Option D. A is equal to R, B is equal to P, wrong, because Clemmensen does not produce a cyclohexene ring. R has an endocyclic double bond unexplained by Clemmensen. Therefore, the correct answer is C. Therefore, the correct answer is option C.